Hello again, and welcome to this lab. In this lab we will continue what we started with last lab or last class. We started with designing the footprints of our project's components. So we designed the footprints of wire to board connector for resistor and for the regulator LM7805. In today's lab, we will continue designing the footprints of the remaining components which we have. So we have to design the footprints for the temperature sensor, the footprints for LED, and the footprint of operational amplifier. I got the dimensions for D, E, and E small from the data sheets of each one of those components. And for the temperature sensor, because we don't have the datasheet on digikey.com, we can use the vernier caliper to get the dimensions of the length, width of the component, and for the distance between the two pins. As we said, you can use the standard distance between the components to be 2.54. I measured it to be 2.2, but you can use the standard distance, which is 2.54 between each two adjacent pins. So now we will again use the software PCB editor to design footprints for the temperature sensor LED operational amplifier with those dimensions here. Also, these dimensions, it will be posted on your course model page. Just a hint for the temperature sensor. The temperature sensor that we have, as I showed you in the first class of the project, that this sensor includes 4 pins. One of them, which is the 4th pin, it will not be connected, but in our case we will design or we will take care about the 4th pin, which means that we will do a hole inside the port for this pin, because we need to insert the 4 pins inside the board. But when we do a connections, the 4th pin, it will not be connected. So this is only hint, you have to take care about it, because again for this sensor we have four pins, but 3 of them it will be used and the 4th one it will not be used. But we have to drill a hole for the 4th pin in order to be able to fix this sensor over the board. So let's use now the PCB editor to design the footprint for those components. So for temperature sensor, D dimension, it will be around 16 millimeter. E, it will be 2.55, and E1 it will be 2.2, or you can use 2.54. For the LED we have this dimensions, and for op amp we have this dimensions. For op amp, because we have 8 pins, so we have extra dimension we have to take care about it, and we will see it when we come to design for operational amplifier. So I will share with you now the software screen of PCB editor, and then later we will start designing the footprints. So this is the last thing we did last time. It was the second footprint for the regulator, and most likely this one it will be used in our project. Okay, so to design the footprint for now, we will design the footprint for the temperature sensor. So we will create file, a new package symbol wizard. We will save it inside the same folder. Now we need to name the sensor footprint. We designed the pad, and not last class, 2 classes ago we designed the pads, and we designed 2 pads, 1 circle and 1 square. We named it sensor underscore circle underscore pad and sensor underscore square underscore pad. So we need to give a name now for the footprint to be sensor underscore foot, and we will use these 2 pads in order to design our footprint. Remember that the sensor including 4 pins in the same direction or in the same side, so I will use SIP again, and I will use 4 of those pins, not all of the pins. I will determine the number to be 4. From here we will choose load template. Then from here we will choose millimeter. and I will give it name S, or you can give it T, like temperature sensor. Then next, from here we need to choose 4, and now for E you can keep it 2.54. I will keep it 2.54 just to follow the standard. And we have D capital equal 15.95, so 15.95, and we have E capital equal 2.55, 2.55. Then we will go next. From here we need to upload the pads which we designed before under the name sensor underscore circle underscore pad, and we need to differentiate the first pin to be sensor underscore square underscore pad. Then next, and finish. So in this case we designed the footprint of our sensor. As we can see, the first pin it's coming a square, and the remaining 3 pins it's a circle. Pin number 4, we will insert the pin inside it, but it will not be connected with any trace. Just we need to save our work from here, and by this we finished designing the footprint of our sensor, digital temperature sensor. The next step now is to design. Let me show you again this document. Now we need to design the footprint for LED with D equal 5.08 millimeter, E equal 5.08, and E1 equal 2.54 millimeter, which is the standard dimension. From where we got those dimensions? Again, from the datasheet. So you can just go to dgq.com, search for LED, and choose the mounting type to be through hole, and then open any datasheet after those filters. Then you will find that the dimensions of D, E capital, and E1 like this. Also, you can come back to lab number 4. You will find also how to get the dimensions of different electronic components. So I will share with you again the software. To insert those dimensions and to create the footprint of the LED. So file, new, package symbol wizard. In the same place we will save it under the name LED foot, and we have 2 pads for this LED, 1 circle and 1 square. So LED foot. Then from here for the LED we have only 2 pins, 1 positive and 1 negative, so we will choose through discrete because it includes only 2 pins. By the way, you can also use SIP, and to choose the number of pins to be 2, it will be working with you also, but let's use this one through hole discrete. Load template, then next, from here millimeter and millimeter. It's LED, so I will give it name L, or you can give it name D, for example. Now we need to enter the dimensions here from the documents that we have. D equal E capital and equal 5.08, so this will be 5.08, and this one will be 5.08. We have E1 or E small, E1 small equal 2.54. Then next, here we have to upload the pads which we designed for LED. So we have 2 pads, 1 circle and 1 square. By default, when you upload the first one, it will come the same for the second one. So because we have negative side here, we need to add a square one. So I will choose the square pad. Then next, and finish. So this is our footprint. We need to save. This is our footprint for the LED. So now we design the footprint for LED for temperature sensor, regulator, resistor, and wire to board connector. The remaining footprint to design is the operational amplifier. So we need now to design a footprint for the operational amplifier. Remember that LM741 including 8 pins. So we need to design now a footprint for 8 pins. So we'll go File, New, Package Symbol Wizard. We design the pads for this component to be op amp. We designed 2 pads, one circle and one square. I will give the name for the footprint to be op amp underscore foot. Then OK. From here, now we have to think about it. For the operational amplifier, it's an IC, integrated circuit, with 8 pins or 8 legs. So as you can see here, we need 1, 2, 3, 4, 5, 6, 7, 8. So we need this part. If I choose SIP, you can see that you can choose 4 from here, but on the other side there is no pins. So this will not work with us. Through whole discrete, it includes only 2 pins, so it will not work with us. So in this case, we will choose DIP because it's the through-hole component for ICs. So I will choose DIP. We are using DIP only if we have ICs, but if we have components like transistor or regulator or sensors with pins in one side, in this case we can use SIP. So we'll choose DIP because we have LM741 IC, then load template, then next millimeter from here, millimeter, and because it's operational amplifier I will give it the name A as an amplifier. Then next, here it's very important to choose the number of pins that we have. The number of pins for the op amp, it's 8. And here, as you can see, there is an additional dimension we have to add. Those dimensions, you will not memorize them, you will combine them with the graph that you have here. As you can see, the length of the component from here to here, it's D. The width of the component, it's E capital. The distance between two adjacent pins is E small. And the distance between the pin and the pin, or the leg and the leg from the other side of the IC, its name E1. So it will be E, the body, E capital, plus the distance that you have in this side and the distance that you have in this side. And this will be given also in the datasheet of LM741. Once we entered here, I will show you how to get the dimensions of this one from the datasheet. Or I can show it to you now. Let's finish the footprint and then I will show you how to get it from the datasheet. So I have it ready here in this document. So we have D capital equal 10.16, 10.16, sorry, 10.16. We have E capital equal 6.6. We have E1 equal 8.26. As we said, E1 here, it should be larger than E capital here. So it's 8.26. And we have E small 2.54. It's the distance between two adjacent legs, and we can use the standard or the international standard for this dimension. So now we are ready with this one. You can move to next. And here we have to enter the pads which we designed for the operational amplifier. So it was op amp underscore circle underscore pad. And to differentiate the first pin, we need to add the square one. So op amp underscore square underscore pad. Then next, next, and finish. So this is the footprint of the operational amplifier. As you can see, this is pin number 1. So by if you know that this is pin number 1, then you will not be confused with the direction of the operational amplifier, how to fix it over the board. So 1, 2, 3, 4, 5, 6, 7, 8. We will use this pins to be combined with other components over the printed circuit board. I will give you now like 15 minutes to try to find the datasheet for LM741 And from this datasheet we need to get the dimensions between two legs here, which is E small, and between the distance from this pin to this pin on the other side, which is E1 small, and the width of the body, which is E capital, and the length of the body, which is D capital. So you have from now 15 minutes trying to find the datasheet and the dimensions of the footprints from the datasheet. Okay. This is the datasheet of LM741. Let me remind you how to get this datasheet. To get the datasheet for LM741, we need first to go to DigiKey website, digikey.com. So once you opened the DigiKey website, as you can see here, then you need to search for LM741. When you search for LM741, you will reach this page. You need to add some filters. The only thing we need to change here is the mounting type. We have surface mount and through hole. We will choose through hole and to apply filter. Once you applied the filter here, you will find different components coming. The one that we have in our lab, you can choose the first one, this one, or you can choose this one or this one. All the same, all will give you the same dimensions. Sometimes you will find some very small difference between the components, but it will work with all of the hardware that we have in our lab. So once you reach this one, you will go to this data sheet here. Once you clicked on this data sheet, you will reach on this icon, you will reach the data sheet, or it will be this one here. We will go to page number 17. You will find the dimensions of the component here. So the dimensions that we have here, as we said, we need the width of the component from here to here. We need the length of the component from this point to this point here. And we need also the distance between two adjacent legs, between this one and this one. And we need also the distance between the leg or the pin and the pin from the other side, which means from this point to this point. So those are the dimensions which we need. So it will be, as you can see, we will take the maximum. As you can see, bottom here you will see 9.02 and up it will be 10.16. So we will take the upper one, 10.16, and as we said, this will be D capital. And the width of the component, as you can see, it's 6.10, so it will be E capital here. You can just go back in this recording to see from the graph E capital and D capital. And also we need the distance between two adjacent legs to be E small, which is 2.54 from here to here, and between the leg and the leg from here to here, this is called E1, so it will be 10.92. In some datasheets you will find it 8.6. In this datasheet it was 10.92. So we will deal with this one or with the datasheet that you got. But in the sensor that we have in our lab, it's dealing with 10.92. So we will take these dimensions and we'll design our footprint based on this dimension. So we have E small, E1 small, and we have also D capital and E capital based on this datasheet. By this we finished designing all of our footprints that we will use inside that we will use in our project. So in the next class and lab we will start designing the board and to wire the components together, and then later we will generate the Gerber and drill files, and I will show you some videos for fabrication and for soldering of the component over the printed circuit board. Thank you very much for listening. Just a notice that this recording, it will be also available on a separate link, so you can visit it anytime you want. Thank you very much.